So we're very familiar with water. We drink it, we bathe in it, we swim in it. It is the most common and important liquid on Earth, but it's actually a very strange substance compared to other substances. It is essential for life. We can't live without water. Water has a low molar mass, and yet it's a liquid at room temperature. Most things with a molar mass as low as water are going to be gases at room temperature. The reason it's a liquid is because of hydrogen bonding. It's the main solvent in living organisms. It's the main solvent in our environment. Most of the liquids that you encounter are going to be water with stuff in it, a solution of water, aqueous solutions. Few exceptions are things like acetone, gasoline, oils, but most things, name a liquid. Coca-Cola, that's aqueous. Pretty much anything you can name is going to be aqueous. It has a very high specific heat capacity. So it can absorb a lot of energy with a small temperature change. And so that effect moderates our climates. It expands upon freezing. That's unusual. Most things shrink as they freeze, but water expands, and that causes what we see in this head of lettuce here. This got too cold in the refrigerator. The water in the cells expands as it freezes and bursts the cells and causes the lettuce to just turn into mush. This is also why if you freeze a water bottle, sometimes it will break, right? Because the water expands and can break the plastic. Here we see the boiling point versus the period in the periodic table. So here we have period 4 elements, compounds formed with hydrogen. This is group 4, and the periods 2 through 5. We see as you go down the periods, the boiling point increases because the size of the molecule increases, and so the dispersion forces are greater. This is group 7 in the green, group 5 in the yellow, and group 6 in the blue. We see increasing boiling points for these other groups because they're forming polar molecules with hydrogen, whereas group 4 is nonpolar. And then we see these 3 guys here. They are not following the trend. All the rest of these are behaving themselves very nicely, and we expect these lines to continue in a similar fashion. But what are all 3 of these substances capable of doing? Hydrogen bonding. ET phone home. Fluorine, oxygen, or nitrogen bonded to hydrogen. There's oxygen. Come on, pointer. Fine. You can see it. There's oxygen, hydrogen fluoride. There's the fluorine, and ammonia, the nitrogen. Any questions? Just a quick word about water pollution. I think we all understand that clean water is very important to be healthy. There are 2 different types of contaminants, biological and chemical. So biological contaminants, microorganisms, viruses, parasites, those typically get into drinking water when waste, either animal or human, is dumped into bodies of water. You can treat this chemically. Bleach kills a lot of it, or you can boil the water, and that'll kill most of the little things living in it. Water like this can make you sick, sometimes very badly sick. Chemical contaminants come from industrial and household dumping. You dump stuff in your backyard, you pour something in the street, the car drips oil, that's eventually going to get into the water system. Also pesticide and fertilizer use. So these are chemicals, they're not living organisms, they're chemicals present in the water. You cannot get rid of these by boiling the water. And in fact, if you boil the water too long, you make it worse because you end up concentrating the chemicals in there. Most chemical contaminants would not make you immediately sick, like the things that would give you dysentery, would make you, you'd be very, very sick in a day or so. These would not make you immediately sick. And they, depending on the level, they might not have much of an effect, but they could. And that's the end.